All right, welcome. Today, we're going to demystify a really core computer concept, Linux system calls. And we're going to do it with a simple analogy that I promise you are never going to forget. Let's imagine a very special restaurant.
I mean, really, have you ever stopped to think about it? Every single time you click a button, type a sentence, or stream a video, there's this secret conversation happening deep inside your machine. To pull back the curtain on that dialogue, we're going to need to visit our digital restaurant and learn the rules of the house.
Okay, so let's dive right in. The first thing you need to know is that our restaurant, just like the operating system it represents, is split into two totally distinct, separate areas. And getting this layout down is the key to, well, pretty much everything.
So, on one side, you've got the dining room. In tech terms, this is user space. Just picture it. It's a bustling place where all your apps are sitting as customers. Chrome, Spotify, you name it. They all want things, but here's the deal. They have zero power to actually make or get those things themselves. Then, on the other side, we have the kitchen. This is kernel space. Think of this as the exclusive high-security engine room where all the real work gets done. Controlling files, managing memory, and talking to the hardware.
So now that we've got the lay of the land, let's meet the key players who make this whole operation run.
First up is our customer. This represents any app you're running. It's sitting at its table, hungry for resources, but it has to follow one very, very important rule. It is absolutely, under no circumstances, allowed in the kitchen.
So if the customer can't go to the kitchen, how does it get what it needs? Well, that's where our next character comes in. Meet the waiter. The waiter is our system call. This is the crucial go-between, the only one with the special authority to travel between the dining room and that all-powerful kitchen. And of course, that brings us to the kitchen itself, which represents the kernel. You can just imagine a big swinging door with a sign that says, "Authorized personnel only." This is the protected core of the operating system, the part that takes all the orders and does all the heavy lifting. Okay, we've got our setting, we've met our characters, so how does a customer actually get their food? Let's follow one single order from the moment it's placed to the second it's delivered. Here's how it all goes down. First, the customer, our app, signals it needs something. Then, it makes a very specific request to the waiter. Maybe something like, "I'd like to read a file, please." The waiter takes that order and zips right through the authorized personnel only door into the kitchen. Inside, the chefs get to work, preparing the plate of data from that file. And finally, the waiter comes back out and delivers that data right to the customer's table. And just like that, the order is complete.
Now, what's really wild is that this whole dance happens invisibly, millions of times a second inside your computer. It's a fundamental process, but it's completely hidden from view. So the big question is there any way for us to actually see this happening?
Oh, yes, there is. And this brings us to what might be the most interesting and powerful character in our entire story. I want you to meet the ghost. In the real world of Linux, this amazing tool is a program called strace. In our restaurant, it's a completely transparent observer, just hovering over the waiter's shoulder. It doesn't get in the way, it doesn't slow down service, it just silently and very carefully writes down every single trip the waiter makes into a little logbook. And this is exactly what the ghost's logbook looks like. It's just a simple, clear, chronological record of every single interaction. Waiter took an order to read a file, went to the kitchen, and returned with the data. It is a perfect transcript of that hidden conversation. Okay, so here's the crucial point. Why is having this invisible observer so powerful? Why does being able to see the waiter's trips back and forth matter so much in the real world? Because this power of observation is a developer's superpower. For debugging, you can see exactly where a request fails. Did the waiter get a bad order, or did the kitchen mess it up? For performance, you can see if your app is making thousands of tiny, slow trips to the kitchen. And for security, you can watch for suspicious orders and see if an app is trying to access things it absolutely shouldn't be. This ghost gives you a deep, true understanding of what your software is actually doing. At the end of the day, this simple idea of a non-interfering observer, our ghost, is a tool for making the invisible visible. And it really makes you wonder, doesn't it? What other complex systems, in technology or even in our daily lives, could we finally understand if we just had a way to watch the hidden messengers at work?